go ahead, thumbs up. So I got to be honest, this is a lot more. I don't know if it's the room or what, but this is a lot more people than I expected. So thank you all for coming. Yeah, studs my notes to take a quick minute to thank everybody for coming. So, you know, you got a lot of smart people, a lot of smart talks. You're choosing to spend 45 minutes of it here, so thank you. I'll try to make that worth your while. This is a talk about Ruby's Singleton module, the Singleton pattern itself, and a kind of a funny thing that I came to understand about Ruby while learning about both of those things. A little bit about me real quick. My name is Mike. I live in Vancouver, Washington, so a suburb of Portland, Oregon. Oh, perfect. Good? All right. Oh, that is louder. To wax autobiographic for a moment, I actually spent about 10 non-consecutive years in Nashville, so it's kind of like being in old stomping grounds. Really like Hattie B's. I mourned the loss or the reinvention of Melrose Billiards. Rest in peace, I suppose. You can find me in places on the internet, comike011. Usually there's that photo of me passed out on a train. It was really hot that day, and that's what was happening. It was kind of heat exhaustion, and there was no air conditioning or windows. I am a senior engineer with a company in Voca. They're based out of Santa Barbara, California. They let me work remote. We work in AI-powered call tracking and analytics, and we're hiring. And I really wanted to emphasize that. So for a second text animation, there will be no more after this. I hope you enjoyed this multimedia experience. But come and talk to me or anybody in an Invoca t-shirt. We're awesome people regardless, or look us up. We have a note on the job board as well. So this talk, once accepted for the conference, underwent this kind of evolution that I kind of wasn't expecting, I won't lie. But I realized it had these three primary parts that we're looking at here. You have the Singleton pattern, Singleton RB, and Ruby Singleton class. And at the risk of being kind of meta about this, talking about the talk, these sections have a narrative about how they led to the other as kind of my research progressed. So how did we get here? The RubyConf CFP opened in July, and I submitted this talk probably about half a month later. I wasn't that quick to it. It was for the core and standard library track. It found a home in the general track ultimately, but its origins were kind of rooted in Ruby's docs. When I decided to submit the talk, I didn't really know what I was looking for, so I kind of turned to the standard library. I was just kind of looking for something interesting, and I found this, Singleton. I've heard of singletons. I didn't really know much about them, had never really used one, and the docs were exceptional. If you can't see it at the top, there's a really succinct description. I'm going to zero in on it here. The Singleton module implements the Singleton pattern. So thank you very much. Again, it's great, appreciate it. I'll take questions later. Kidding. So let's naturally start at the middle, let's get away from the middle where we started and kind of go back to the beginning. What is the Singleton pattern? And the Singleton pattern is one of the Gang of Four design patterns from the book Design Patterns, Elements of Reusable Object-Oriented Software. And there are a few characteristics of singletons that are both objective, and I'm not really going to call it a characteristic, it's a subjective thing I found. The slides will talk about it. For starters, though, they restrict the creation of a class to a single instance. They provide a single access point to this single resource. There is one instance of a class, and we always have a mechanism to gain access to it, no matter where we are kind of in our application. And while it has a global purview, it's not necessarily a global variable. Well, necessarily is not needed there. It's not a global variable. It's an instantiated class. Its attributes don't occupy space in the global namespace like you'd see with global variables. Also, they don't exist until instantiated, unlike global variables. And then there is concern about its application, and this is kind of the more subjective aspect of it. Some of you may have already considered the ramifications of global variables. I think a lot of us are kind of naturally inclined to hate them. You might think about tightly coupled code, which is why we kind of shy away from global variables. Test files that are more stubs and mocks than they are actual software tests. And you wouldn't be alone in this. The more I read about singletons, the more opinionated the internet became, which I was shocked by. Here's an example. We have "Are singletons bad?" And that's fair enough. We're just asking a question here. And you'll have to forgive me. I'm going to stop making eye contact for a minute and read directly from the slides. I didn't memorize these quotes, but he said, I agree the singleton pattern seems convenient and it may occasionally be warranted to use it, but the drawbacks far outweigh the benefits. All right? This gentleman came through with 6 reasons why you should avoid singletons. He only came up 6, so that's not terrible. He said, yes, I'm really writing a blog about why the singleton pattern is bad in 2016. But it comes up in discussions time and again, so here is a list of reasons why you should avoid singletons. The downside for this is this post came because this poor gentleman was always having to talk about singletons. So it's like, I'm going to put myself on the record this one time, no more conversations. And it just kind of kept getting worse. This was really bad. This is the last one I'll quote from. The rest I'll just kind of be kicking a dead horse with the titles of the articles. But most of the patterns from Gang of Four are straightforward and frankly plain logical. However, there is one specific pattern that gets hate from every code-related website on the internet, the infamous single pattern. Infamous. Probably the most overused and frequently misplaced programming anti-pattern of all time. So infamous and anti-pattern in the description. This is not going well. Yeah, these next few, again, I won't quote from. I'm just kind of kicking a dead horse with the research. Why singletons are evil. Singletons are pathological liars. Patterns I hate, number 1, singletons. I love LCD sound systems, so this one struck a chord with me. Singletons, I love you, but you're bringing me down. And allegedly, there were some defenders out there, but I was having a really hard time locating them. So what are the concerns with singletons? I mentioned problematic misuse earlier, but let's look in somewhat greater detail. They allow for multiple points of access to the same resource. And this isn't necessarily a problem if it's immutable, but if they can alter that shared resource, you're going to get into some trouble. It's very problematic. Which brings me to the second point. You could be introducing an object that is globally accessible and thus globally alterable. If it's manipulated in one area unbeknownst to another, it would no longer be predictable. There would be potentially different responses for the same action. That's a big no-no. They're a violation of the single responsibility principle. These objects are concerned with maintaining a single instance of themselves, but then also they have all of the stuff they're actually doing as the object that you've implemented. So that's 2 things. And then there's these questions I kind of raised earlier about testability. If wielded improperly, there could be a circumstance where you're stubbing or mocking the singleton for every test, especially if there is some kind of ill-advised updates being performed to make kind of the expectations more predictable. And this brings up my final point, and this is a single entry to a shared resource, so it just kind of screams tight coupling. I came across a good example narrative that I thought was illustrative, though somewhat contrived and probably begging the question about is the singleton good a little bit of pattern quality. But it was through the lens of a user management application. Like one could say if you built an application to manage a single logged in user, you're going to need access to that user's attributes throughout the application. So you you make that user a singleton. And then when you can pull it into whatever context you need it pretty instantly without constantly having to reload it or anything. But I don't know, like user changes their email address or gets married and changes their last name or moves, that happens all the time. That could change in one place, but other parts of the application that are using that information don't necessarily have not necessarily pulled that in yet. They'd have to kind of go through the reloading process. It just would be a bad kind of tangled mess. I guess it becomes kind of hairy. That's what I said in my notes. So that said, I don't want to suggest the singleton is a universally bad idea. I think we kind of established there's plenty of writing on that already. But some smarter people than me have put it forward as a usable design pattern, and they had a reason for doing that. What I will put forward is that singletons are best used in circumstances where there's kind of this unidirectional flow of data. In other words, exchanges where there's no expectation that values can be altered based on the request. In cases where this class is used universally or sort of in disparate areas, there is a context where you could accomplish this through dependency injection, but maybe sometimes that's kind of tedious because you'd constantly be passing this object to all these disparate areas that maybe necessarily don't have a reason to get it like on their way to where it's needed. This seems like a natural insertion point for a singleton. You can kind of pluck it out of thin air as needed if it's just like one specific instance. A common use case is logging. Having a single logger class in your application that is accessible globally is probably not the worst idea. I think everywhere we could use some more logging. In principle, the request should be consistent. You send in information you want logged, and it is logged, and maybe you get back a true or false if the log broke somehow. I don't know, how often do loggers break? Information flowing one direction, from the application to the logger, that's it. Also, loggers are probably going to be needed universally. I kind of already touched on this. If you introduced it through dependency injection, you'd be passing a logger into all of your classes. That feels tedious. Another example are configurations. Again, it's unidirectional, this time flowing into your application. Ideally, our configs for, I don't know, passwords and stuff aren't changing that often, maybe API authentication tokens. You need them, you might need them globally. They'd be there ideally unmodified, which again is probably a wider net than should be cast. But we want to avoid anything that can be altered by the application in a globally accessible object. And I say internally here, I want to call that word out specifically. In Invoca, we have a few situations where external to the application, YAML files, whatever, have some settings in them. They can be altered, and the singleton that we're using to maintain our configs will pull those in and will not be allowed to be altered within. Oh, that wasn't smart. Will not be allowed to be altered within the application, but are altered externally, and then they're in a consistent state for the application to use. So the concept of the singleton pattern established, we could talk about kind of the lesser dense part of this talk, which is singleton RB. I mean, we already have read the docs, so we know all there is to know about it. Singleton RB is kind of where this all started when I found it. And knowing what has now been said about the singleton pattern, I thought and kind of still think it is curious that there is a module dedicated specifically to this pattern. And while it's not in standard library, it can be included and required and leveraged pretty easily. The module does a lot more things than I'll kind of step through here. I'll kind of gloss over it a little bit. But I'm going to step through what I think are the kind of the more key ones where key is defined as implementing the hallmark aspects of singletons. So as established, a key characteristic of the singleton is that there is one instance of this designated class. To accomplish this in singleton RB, we get rid of, the new method becomes private and is replaced, or new and allocated, excuse me, are made private so they can't be directly called. And they are replaced with instance, and this instantiates the object, or pulls the one that's already been instantiated into your context so you have it. Clone and dupe are made to raise type errors. And again, this gets back to characteristics of singleton. There's only one of them. You don't want to clone it. You don't want to duplicate it. Those will throw errors. And we can take a look at a little bit of this in action. So here is an aptly titled singleton example class. The singleton is included, giving this class the properties of a singleton. We have one attribute that's named the goggles, and we have a method that when invoked returns something. That's a classic joke. Say something. In action, this looks like this. I've included the file containing the previous class, and next I'm going to attempt to create a new singleton example object. Any ideas what will happen? Look at that. You know, see a little bit about where I keep my RubyGem files as well on my computer. Yeah, we tried to call a private method on this class. It failed. The information, error message is informative. Doesn't necessarily tell us why that happened, but I mean, we built the app, we know. So let's start over. We'll use the appropriate method. We have instantiated our singleton class. And I want to display its object ID here on the screen. In case this is new terminology, with a few exceptions, the object ID is a pointer into a location in memory where the actual object data is stored. It depends on where the system decided to allocate the memory of the object. It's not really a property of the object. And again, I'll try to use some understood to be broken functionality of the class and duplicate a singleton. And a little bit more descriptive, this time we actually have the word singleton in the error message. In effect, what the app is really telling us is this. And I'm going to make a confession here briefly. I have never seen Highlander. Someone told me this was a good gag. Tepid reaction, I won't lie. Next draft, I'll get rid of that. So I created another instance of my singleton here and assigned it to the aptly titled another test. This is going to be like a little bit of a tongue twister. That was a bad choice in names. And I pulled up its object ID as a means to prove that there really is only one of these objects. We see it has the same object ID as our previous, well, I don't really see it on the screen here, but it has the same object ID as our previous just test. In fact, I'm going to try to do this comparison. And ordinarily, we would expect these to be different. Two objects, two object IDs, that makes sense. So they are not equal. False. There cannot be two instances of this. In fact, if you ask the question, can there be two instances of singleton example? Yeah, no? That reference I actually got, so I wanted to include that one. Sorry. So I wanted to dig briefly into the attributes of a singleton. Back in the class definition, there was an attribute called the goggles. Here I set the attribute to be do nothing. This will be the last cultural reference. I was kind of worried that this one wasn't going to land and maybe date me a little bit, but a friend pointed me out that early Simpsons episodes are totally timeless. I'm also going to... Regardless, we set the attribute for a test, and without prompting it in another test, it's there as well. So it's almost as if these are the same objects. It's almost as if these two objects are the same, which we know they are. Okay, enough about singletons, the pattern, enough about singletons, the documented Ruby module. Let's talk about the rules, excuse me. Let's talk about Ruby singleton class. And transparently, while working through this proposal, this is where I got really curious about the singleton pattern. Amazingly enough, not in a largely criticized research on the internet and not in a very light on description gem or module, excuse me. And I want to be honest and say that a lot of this is based on coincidence, probably more than anything. I stumbled onto this very small module that implemented a controversial design pattern, according to the internet, and it really had me thinking, why? And this was when I think it got interesting. So let's look at the Ruby singleton class. I have seen these referred to with a few titles, but for purposes here, I'm going to stick with singleton class. And it's with good reason. They're accessed by calling that on an object, singleton underscore class. We'll come to that in a little bit. These are somewhat hidden, and I say somewhat because they're kind of in plain sight. They can be displayed relatively easily, but don't really show up in any observable way unless you go looking for them. I kind of think of it like gravity. I can't see gravity, but I'm very concerned right now with tripping over my own feet and experiencing its effects on camera, and it'll be subsequently made public by Confreaks. So thank you guys. And lastly, they're essential for the Ruby object model to work in our applications. So let's talk about that briefly. Here's a crude diagram that I made to be illustrative. And it's a hierarchy of objects, starting with basic object at the top, to object, and to our defined class at the bottom. And that defined class can be whatever we want it to be, dog, conference, rostrum, nervous speaker, whatever. This also has an included module kind of off to the side there. That's the dotted line. As Ruby practitioners, we say in here a lot that everything in Ruby is an object, and that is true. And all of those objects inherent from object and basic object in that order. This is true for custom classes as reflected in this diagram, or classes like nil or integer. Modules that are included in classes aren't reflected in the object's hierarchy or are reflected in the object's hierarchy before that model. As in the example in the diagram, our defined class would include a module and is reflected as the next level up if you did define.ancestors. I think I have an example coming up here. Yeah. By way of a really contrived example, I created this class conference talk. And we see this object model realized by calling ancestors. There is the object and basic object. Kernel is included in module and object. It does some super useful stuff, puts, require, I think caller is in there as well. It's a little beyond the scope of what we're talking about here. And here are the ancestors for the string class. And we can see that the same pattern emerged, but with the noted exception of comparable is there. And this is another included module. This time it's included by string. In fact, that module can also be included in my contrived conference talk class from earlier, and we see it in its ancestors, included right where we expect, just above the defined class. So enough about the object model. Let's talk for real now, I swear, about the Singleton class. And I've been told and have experienced, almost ad nauseum at this point, that it's not really a technical talk without something about cats. And this probably seems very true for RubyConf especially. So these are my lazy two cats. On the left, I think that's you all's left, right? Yeah. On the left is Porch Cat, or PK, for short. And before I get any feedback, these two, about how cat doesn't start with K, so that doesn't make sense, sometimes she goes by Kitty. Like, that's her choice. I respect that. My name's Michael, but I go by Mike, and the K shows up in there. So anyway, her name comes from this kind of rags to riches story. Right here in Nashville, she showed up on my porch shortly after the West Nashville flood in 2010. And on the right here, that's Pearl. No association with the other programming language. Her name actually lies, that was just a decision my wife made before we met. They named her that when she was adopted. Honestly, I wasn't trying to live this two-cat life, but time makes fools of us all. So here's a small application to mimic the bulk of their activity. Not a whole lot going on. There's a single attribute description, a single method, speak, that just kind of purrs. And just briefly in action, an instance of cat is created to represent Pearl. She's a little tabby cat. And she can speak. And this is what has been created kind of under the hood. Pearl, the instance of cat, has its attribute description and a pointer to its class, which is cat. Cat has the speak instance method and a pointer to its class, which is the class for all classes in Ruby, where things like Nuke are kept. And a pointer to its superclass, object, which harkens back to the original diagram of the Ruby object model. And the thing I want to note here is that Perl is aware of its attribute, but it has no idea it is a method speak. And this is this is how method dispatching works. When a method is called, Ruby traverses its class pointers looking for that method. When Perl is asked to speak, the application will look for and find that method in cat, then call that method on its current value for self, which in this case is Perl. I said class like 15 times in that sentence, so I hope that tracked. And I'm not really sure what the end goal of this class is, other than to be contrived and an example. But here are just a few small adjustments. For starters, the class variable houseCats has been added. Since this is a class variable, it's going to be shared across all instances of the class cat. The ability for a cat to move in has been added, regrettably, and that's not true. And this is a class method that adds the given cat to the houseCat's class variable. And lastly, class now has a class method in-house that just outputs the cats that are currently in the house. I need to take a sip of this water after saying class and cat that many times. No, she moved into the house, no matter how rickety the house may be. Porch Kitty hadn't moved in just yet. She was truly living on the porch. That was a makeshift shelter she had. To put some of this back into action, we can go back to Pearl. And she can move in. Then I can use the class variable that shows me the cats currently in the house. Yeah, Pearl has moved in. And I'm going to skip a few lines here, so I'll kind of just step through it. We created another instance of cat for Porch Cat. Yep, Tabby spotted, there she is. And she can also move in. And so now I can call the class method in-house, and I can see the cats are in the house. They have become house cats. And in reality, with PK in the house, good luck getting any work done. That's me trying to do some work. And Pearl does not like this new roommate because she had free reign. But anyway, going back to this diagram, for just Pearl here, like we have Pearl at the end, what is interesting is that while we've added these two class methods to cat, move in and in-house, this diagram is still accurate. Class methods aren't represented in it for good reason, because where would they go? Because of how method dispatching worked in the example, where we asked Pearl to speak, cat wouldn't be able to call move in on its current instance of self, because there isn't one. It's cat. If we tried to go to the next level up, we'd go to class. And if we defined move in and in-house on class, then every class we instantiate from that point forward gets those methods. So I could have a dog. You don't really have a house dog. That doesn't make any sense. But yet it has that ability. So this is where the singleton class comes in. And there it is, represented by that little hash in front of cat. Ruby creates the singleton class for the specific class or object. It's generally hidden, but following the same message dispatching, when cat.moveIn is called, Ruby will traverse the class hierarchy to the cat singleton object, singleton class, and find its moveIn method there, and then call that method on self, which is cat. So now we can actually see how that operates. Moreover, something similar can be done with the instantiated objects themselves. Kitty makes this noise sometimes. That when she first became an indoor cat, my wife and I were very worried that she either hated us or did not want to be an indoor cat or was in some kind of distress. The most embarrassing part about this talk is when I will try to imitate it, but she was like, ow. It echoes throughout the house. We subsequently found out that she only makes that noise while she was playing with some kind of like a knit or textile, a winter hat, a scarf, thick socks, but she doesn't want anyone to see her do it. So as soon as you see her, she stops and just looks at you like, what? Regardless, I'm going to add this capability as a class. I'm going to add this capability as a class method to porch cat directly, PK being an instance of the class cat. And here, PK is asked to speak, and she makes that noise, and I am woken up at 2 in the morning. But Pearl still has the regular old speak method that we defined on cat way back when. So what happened? It's the same that we saw earlier, except for the instance of cat and not for the cat class itself. PK also gets a singleton object, or a singleton class, and it implements speak. So when we go through that message dispatching, as you're going to say pk.speak, and it's going to see speak is now defined on its singleton class, and cut that path off and never get back to cat. Whereas for Pearl, she doesn't have speak defined in her singleton class. She's just going to go right up to cat, see speak there, and just make that purr noise. The singleton class method exists to reveal this class, and here is the singleton class for PK. Generally, it has this kind of naming convention of the class, colon, and then, the original object, pointer in memory, the location of PK. Here's a singleton class for cat. It's the same naming pattern. Class, name of object. Here it's cat. And we can see that despite it being defined in the class in the Ruby code, cat does not have those class methods we defined. But cat singleton class has the move-in method. And so now these cats are moving in, and they sleep comfortably, as you can see. And at the risk of picking on PK, but it's necessary for this example, she does this thing when she sleeps. It's kind of like a wheeze. It's not really, it's super quiet, but it's not definitely audible. And so we add this capability, again, directly to PK. And she can do it. PK.snore, she wheezes. And then, seen as part of the PK singleton class, we see it's been defined, PK.singleton class, method defined. Sorry, I'm reading from the slide. And not on the object itself, the instance of cat PK. And no, I'm using method defined. Method defined is a module of class and not on the instance, so that's why I abandoned that method defined pattern, went to methods include there. Also, Perl has been totally unaffected by all of this. Her instance does not have any class or singleton class updates by adding snore to PK. I'm not convinced she actually sleeps. She watches you sleep. It's unsettling. And so I wanted to talk and close out these examples about cats with a famous cat, not Garfield. This is meant to represent Schrodinger's cat. Schrodinger? Dinger? Okay, Schrodinger. For those unfamiliar with things other than its pronunciation, the summary of Schrodinger's cat is that Schrodinger hypothesized if he put his cat in a box with something deadly, like a radioactive atom, because we have those laying around, and sealed it, he wouldn't know the state of the cat without opening the box. This cat would be both alive and dead in his kind of capability of observation. And this is really silly, but to be illustrative, the status of the cat is meant to be private and can only be seen by checking the box. And in execution, that is exactly what happens. But there's an issue. I shouldn't be able to look at the status of the cat without checking the box, and yet I can. Why can I call this private method that is a class method? And we kind of already know why, because we've been looking at method dispatching. And there's a lot of solutions to this. I think there's a defined private method or private class method. Also, I don't know, if you're really doing this, I kind of would ask, like, you really want a private class method? That doesn't seem like a good design choice. But this is an example at a conference, so. We can manipulate, our solution will be that we're going to manipulate the actual singleton class. Here the syntax class, char itself, actually manipulates the singleton class of the cat object. Then private can be added because we're really adding a private method to the singleton class, thus hiding the status method from the public's prying eyes. And we can see Schrodinger's cat didn't make it again, but we can't cheat and see the status of the cat without first opening the box. And I wanted to wind down by reconsidering how we got here. I don't feel qualified to make a definitive statement on the quality of the singleton design pattern. That's something smarter people, I said this earlier, smarter people than I wrote about it. They had way more experience. But this did just all start with an overview of a controversial design pattern that was learned about while looking at its implementation in a small, well-documented, Ruby module. And this led to learning about Ruby's message dispatching pattern. And it raised this question to me about how interrelated these concepts are. And probably on a more grand scale, all the derision directed toward the singleton pattern, how necessary is it really? To me, learning on this, I was surprised and fascinated kind of as each piece of this kind of proverbial onion peeled back, revealing a pretty elegant, well, what I consider to be elegant, everybody has entitled their own opinion, the internet will hold them for you, elegant solution to method dispatching. It was a pretty elegant solution to this that made use of something that was so publicly dismissed and derided. And it reminded me of, maybe sans the derision, but there's 22 minutes east of where I live in Portland, Oregon. There is this guy, his name is Bruce Campbell, not that Bruce Campbell. He bought a decommissioned 727 and he parked it in the middle of the forest out there. There's a national forest, I think he ons part of it. And he lives there for 6 months out of the year while he works on this plane. And he tinkers with it. You can't really see it, maybe in the blown up version. There's like a light stream that comes off of it for his little patio area. He's made it more and more livable. He's added plumbing, he's got electricity, he's got water. I said plumbing already. And it's probably quite bigger than most available housing in Portland these days. And I bring up the story about Bruce living in the woods in the 727 because he took something that was discarded. I mean, he paid for it, it's salvage, so not discarded exactly, but he found this use for it. And it's pretty unique use and pretty amazing use. But it made me think about how quickly concepts can be disregarded because of bad experiences or exposure to negative opinions. When I first started researching this talk, it'd been real easy to look at all of the writing out there about the singleton pattern and go, well, this is garbage, and move on. I probably wouldn't be speaking here. It probably made my life a little bit easier, honestly. But something just kind of didn't add up about why there was this module. And I can't say that there's any necessary connection between the module and method dispatching in the singleton class, but it seems suspicious. There's people here that we could ask that might know the answer to that. but I believe there are some larger takeaways. Context matters. Understanding appropriate use gives concepts value, and be dubious of absolutes and blanket statements. While it is true that every problem looks like a nail, if your only tool is a hammer, it'd probably be just as bad to pound away on that nail with a saw, especially after you just got done reading an article about why hammers are garbage. We get to stand on the shoulders of giants with the tools that we wield and the philosophies we leverage, because, as I've said several times, there's a lot more smarter people out there than I that have wrote a lot of amazing things. But it is still up to us and our responsibility to understand them and to use them well. So thank you again for spending this time with me before lunch.